we have to include math.h header file to use these functions. They are trigonometric functions, hyperbolic functions, logarithmic, exponential, square root, cube root, then absolute value, then truncation in all forms, adjustment, then to find maximum, minimum, to check whether any number is bigger than another or smaller than another, and multiplication and addition combined function. Also to separate the fractional and integer part of the given number. So let's check all of these one by one using our compiler. Okay, let's go to our compiler. So I have included this math.h. Most of the functions, they work on the floating values. Okay, so we will read the value. Let us first see sine cost. So most of the time we'll define everything float. We have to give the angle in radians for the functions, but normally we give degrees. So let us read the angle in degrees and then convert into radian and then see how the sign is given. So let's take the angle in degrees from the user. So enter angle in degrees. This message will give to the user. So user will enter the angle, maybe 30 or 45, whatever angles are known that we can give. So %f. Here actually degrees angle you can take radians in integer also, no problem. Now we have to convert this degrees angle into radians angle. So radians angle, radians is equal to, we know that pi means 3.14 is 180 degrees. So 180 degrees is pi. So whatever degrees user has entered has how much, that we have to find out. So that will be equal to the angle in degrees multiplied by pi, that is 3.14 and divided by 180 will be the answer in radians. Okay. Now we have to find out the sine of this angle. Sine of this angle, let us print directly the sign. So printf sine, we can take degrees in integer also, no problem, integer. That will be convenient, unnecessarily. Okay, let it be %f sine of this angle is equal to %f the actual sine. So here we should provide the angle in degrees and sine of angle in radians. Sine of angle in radians. Okay. So let's see the output, what it comes. So suppose user enters 30, then sine 30, 0.00 will be equal to whatever is the answer that will be displayed here. Let's check. Warning. %5 number, yes, %f. Enter angle in degrees. Suppose 30. So 30, its sign is displayed. So let's check, suppose one more angle, 45. That is 0.7. Let us check one more. We know that 90, it is almost 1. So it is 1. In this way, you can have the cos also. You can have the tan also. So let's do this. So let's do it here, cos. Here also cos. Here let's get tan. So here you will get tan. Okay. And we have to get all these values on next line. So let's use \n for next line. So enter angle in degrees. Suppose I enter 45. We know that sine and cos of 45 are same and tan is almost equal to 1. So it's working fine. You can give any other angle also, whatever you know. Suppose 60. Then sine is this, cos is this, tan is this. Okay. So this is about sine, cos, tan, etc. Then the next functions are logarithmic, log x, log 10x, exponential, power. Those we will see. So the functions are very simple. They just give log of x, gives the log of x. So let's take the value float x and take the value of float x from the user. So printf enter number. This is this scanf. Most of the functions they work on floating. So let's use f so that we can give any numbers, integer as well as and x, integer as well as floating numbers. So we have got here. Let us define one more here, that as answer, and we'll equate this answer to whatever log or exponential, anything. So answer is equal to, now let's use log. Log of x is the answer. So answer will be equal to log of x. So printf log into bracket %f bracket complete. This is for x is equal to %f. This is the actual value of log. So here we will provide x as well as answer both. So let's run this. Some of the logs we may remember, so we can check them. This log is log to the base e. This log is log to the base e. If you want log to the base 10, then you must give here log 10. Expected semicolon. Let's do it again. Enter number. So I enter any number, suppose 10. Log of 10 to the base e is 2.30. We know this, 2.303. Log of 10 to the base e. You can give any other number. Suppose I enter 20. So log of 20 to the base e will be this. Now let's do it with log of 10. So log of x to the base 10 we are. Now we know that log of 10 is 1. Log of 10 is 1. Log of 100 is 2. Log of 100 is 2. Log of 50, do you remember? 1.68. So in this way we get a log. Okay. Now exponential. Exponential means e raised to x. So here if you use exp, you will get exponential. So here exp, exponential of x, that is e raised to x, is what? That you will get. So e raised to 1 is actually e raised to 1. E raised to 1 is, we know what is the value of e. Now 2, suppose e raised to 2, you get this. You can give value of x anything. Suppose e raised to 1/2 you want, then you can give 0.5, 0.5 as x. So e raised to 0.5 is this. You can give negative value also. Suppose you want minus 2.4. So e raised to minus 2.4 is this value. Do you understand this? So you can give any value of x, positive, negative, integer, floating, e raised to that value we are getting here. Okay. Now power. Power is x raised to y. So we must define here y also. And answer will be power, very simple, power x comma y. That's all. So x raised to y will get. So here we'll say that x raised to y. Now in place of x we'll write here percent f. In place of y we'll write here percent f, and in the list we'll add x and y. X and y. And answer is equal to x raised to y. So suppose we give x equal to 2, y equal to 4. Then 2 raised to 4, 16 will be the answer. In this way, it will work. Again, you can give any values here. Enter num. We should change this. Actually, we should read the values of x and y both. So let's stop the program execution. And here, enter x and y. Here also. Percent f and x and y. Compiler did not give error. This is because if you don't specify any values, then it may take them any random values. It doesn't wait for you to send the values. Okay. So here we'll read x and y, and then the answer will be failed to connect. Retry. So let's save this. While retrying, if the program goes, then we must save this. It is trying to reconnect. So run this. Enter x and y. No, it's the old program. So while reconnecting, it has not updated the program. So enter. Why it is coming enter? Let me check. Yes. Now it has reconnected properly. Enter x and y. Suppose I enter x and y. Suppose I enter 2 and 4. 2 raised to 0. Scanf, comma, and y. Enter x and y, percent f. Here also the wrong program it has taken. That's why this is happening. Okay, let's do it again. Enter x and y. 2, 4. 2 raised to 4 is 16. Very good. You can give any values. Suppose 5 raised to 6 you want. You get this value. You can enter float also. Suppose 3.4 raised to you want 2.9. Very odd. Still, it is calculating the answer. So in this way, you get power. Now you can find out square root also. Square root is found for single number. So let it be only x. Enter x. We will find the square root of x. So let us change this. Square root it is finding. So answer for square root SQRT. For cube root CBRT. That's very, very simple. So here we will write down that square root of percent f is percent f. Now we will give here x and the answer. Let's run this. Enter x. Suppose I enter 4. We know the answer is 2. What happened to this program? Internet connection is very bad. X is equal to 4. No? Let me check. So connected again. 4. Yes, square root of 4 is 2. Now let's give any other value. Square root of 25 is 5. Now give any other value. Suppose we want square root of 500. It is this. So whatever value you want, you can give the input value also in 3 like this. Any real value. Then still it will find out its square root. To find out cube root, just CBRT. Here also we will write cube root. Cube root of this. So let's run this. Which cube root we want? No. Suppose 81. 81 is 4.32. Which cube root we know? 343. 343. Cube root is 7. Yes. So you can give any value. Suppose 1000. 10,000. By mistake I have. So whatever is the cube root that is given. Okay. Next, it gives the absolute value also. For ABS, just you have to give FABS. FABS. That is function to find out absolute value. Normally we know if we give the value in positive, ABS equal to percent F. If we give the positive value, then its value is positive. Otherwise, it is, if you give enter negative value, then it is converted to positive value. So, answer. So, absolute value of percent F, that is the original value x, is equal to percent F. This. So, x. So, in this way, we can have the absolute value. So, enter x. Now, suppose I enter x as 10. Sorry, I have to enter x here. I will just rerun the program. Enter x 10. Absolute value is 10. But if I give minus 46, absolute value is plus 46. That's all. Very simple. Now, we have to check the truncation functions and understand them. In case of truncation, there are 4 types. Truncation means totally the fractional part is cut. In case of floor, the value of x is just less than argument. So in case of positive number, suppose it is just less 3. But in case of negative number, as a number wise, it goes slightly bigger. Seal means it rounds to the greater than argument. And round means to the nearest integer. Now for that, look at this table. Suppose the value of 3.78. When trunk, completely 78 is dropped. When floor, it is going to the nearest lower integer, that is 3. With seal, nearest upper integer, so 4. And rounding means it checks whether this number fractional is bigger than 0.5 or smaller than 0.5. Bigger than 0.5, then towards 4. Smaller than 0.5, for example here 3.29, it will go to 3. In negative numbers, some opposite things happen. In negative number, in case of trunk, it is just cut. In case of rounding, it goes toward the nearest number. But floor, it goes to the lower value. So 3.67 is bigger than minus 4. So it goes to minus 4 for floor and minus 3 for seal. Same value if it is 0.42. Okay. Now let's see maximum and minimum number between the two numbers. Let's see maximum and minimum. So let's go to our compiler. So you can give any two numbers, suppose x and y. Then there is f max. F max generates the maximum of a and b. So we'll write here max is equal to and the answer. This is the answer. So maximum value is allocated to a and s. Okay. So f max is a function which returns the value which is the maximum between x and y. So here we will get the values of x and y from the user. So here get both the values x and y and use this. Enter x and y. Enter x and y. Suppose I enter 10 and 20. So maximum is 20. Suppose I enter the values minus 56 and 20. So 20. And if I enter minus 10 and minus 74, suppose maximum is minus 10. Similarly, f min finds the minimum values. So here minimum. So if I enter the value, suppose minus 20 and plus 20. So minimum is minus 20. If I enter two values 29, 74, 29. So in this way it gives the minimum value. So these are very simple functions. One more interesting function is FMA. FMA function does the calculation of x into y plus z. MA is multiplication and addition. So FMA. It works on three numbers x, y and z. It works on three numbers. So we must read three numbers from the user. We must read three numbers from the user. We must define also three numbers. So three numbers x, y, z are taken from the user. Enter x, y and z. Three numbers user will enter. Three numbers will run. FMA. F is function for multiplication and addition. So x multiplied by y plus z. This will be done. Okay. So here I just write answer is equal to multiplication x into y plus z. Answer x star y plus z is equal to this. Let's run this. Give simple values x, y and z. Suppose I give x as 10, y as 20 and z as 50. So what is the expected answer? 10 into 20, that is 200 plus 50, so 250. So it is giving 250. Okay, so you can give any numbers and get the answer x into y plus z. One more interesting function that divides or separates the real and integer part, but it works on double. So we must define the number as in the form of double, also its integer part, its float part as double. Now let us ask the number to the user. Enter number. So user will enter the number. This number we have to read. So, but as this is defined as double, we must say here %LF for double and then read that number. So we get that number. Now the function is, we have to get the number in real part as the function is MODF. MODF. Then we have to give in bracket the value of x and the address where to keep the integer part. You have to remember the syntax as it is. After that, int gives the integer part and float gives the real part. So let us print both. Printf integer is equal to %LF and say on the next line backslash n real or real part is equal to again percent lf, and we have to give here our variable names, whatever they could be x, y, anything, and f, l, o, t, they could be anything. Okay, now let's run this program. So any number we have to enter, run this program. Suppose I enter 34.89. So 34 is integer part, 0.89 is real part. Try one more time. Suppose I enter the number 456.9876, some number. So it separates this way. Now let's use these functions. We know that we can find the roots of quadratic equation. The quadratic equation is normally ax square plus bx plus c in this form. So we have to give a, b, c values for the quadratic equation. So let's define them as maybe float. In case of math.h, a, b, c, define everything float, and there will be two roots, so r1 and r2 are the two roots. We know the formula also. So for the equation ax square plus bx plus c, we have to give the values of a, b, c, and the roots are minus b plus square root of this upon 4ac, or minus b minus square root of b square minus 4ac upon 4ac. Now let's use this in our compiler. So let's read the values from the user. Printf enter a, b, c. So user will enter these values. We have to read these values. So and a and b and c, don't forget and. So we have three values. Now we have to write down the equations. So equation will be root 1 equal to bracket minus b plus sqrt, again bracket b star b for b square minus 4 star a star c, so 4ac. Then after this complete bracket b square minus this, we have to do bracket 2 star a. This is the first equation. Exactly similar second equation with the sign change. So R2 is equal to, here the sign will be minus. So in this way we get two roots. Now we have to print the two roots. Printf roots are %f and %f, comma r1 and r2. So these two roots we have to print. So enter ABC. Suppose I enter 1, 2, 1, simplest equation. minus 1, minus 1. 1 to 1, minus 1, minus 1. Let me check. One more example. Suppose I give 1, minus 1, minus 6. The roots are 3 and minus 2. So in this way you can check any roots. Let's have one more example. For example, suppose I give 6, minus 5, minus 6. 1.5. So whatever are the values, they will be given. Okay. Let's do something else. Let's check whether the entered number is prime or not. So get the number from the user, and that number may be, suppose entered number is n. Okay. So n number will be entered by the user. So let's get this value. Printf enter number. So user will enter the number. Let's get this value. We are getting the values to check prime number in integers. So here it is integer and n, and n is the value entered by the user. Now we know that in case of prime number there are different cases, 0 and 1. They are not defined as integers. So if user can enter any value, so if n is equal to 0, this condition is there, then we must say that it is not defined. Okay. So if this is the condition, or n is 1, still it is not defined. So in both these conditions, we must say that it is not defined. So printf not defined. Not defined. We must say that it is not defined. Second case, else if the number is 2 or 3, it is always integer. So if it is 2 or 3, we know that they are defined as prime before any checking also. So printf this number is prime. Now we have to check for other numbers, bigger numbers. For bigger numbers, suppose n is 1000, then how many can be the factors of n? Up to how much you can check? You know that the bigger number than 1000 cannot be the factor. So smaller number. So you have to check the number up to n minus 1. Now if you think more, the number can be, if it is divided by 2, then up to half it can have the factors. It cannot have any factors more than half. So you have to check only up to 500. If you think more, then you will understand that for any factor pair means the pair of numbers which multiply the number n, one of them is always less than square root and another is bigger than square root. So up to square root is sufficient to check. So from 2 onwards up to square root, checking is sufficient. Again, if the number is not divisible by 2, then is it necessary to check by 4, by 6? Not necessary. So if it is not divisible by 2, then just forget checking. Otherwise, from 3 onwards, check up to square root. So else if the number is divisible by 2, then it is not prime. If it is not divisible by 2, then it will not be divisible by 4 also. So don't check that. To check whether it is divisible by 2, n%2 is equal to 0. Means it is remainder is 0. In that case, we know that it is not prime. So printf not prime. Now under this condition, if it is divisible by 2, we say not prime. Now the next condition will not be checked. Under next condition, the number will come to this else part of the program. only if the number is not 0, not 1, not 2, not 3 and not divisible by 2. Now we have to check the numbers from 3 onwards, only odd numbers. So now we need a counter for this. So let's define one variable I. So for I, the value of I, initial value is equal to 3. The last value is up to square root. So I is less than or is equal to sqrt of n. So up to square root it has to check. And every time I will be incremented by 2 because only odd numbers we have to check. Under this condition, what we have to do is we have to check whether the number is divisible by I or not. So, and in for loop, if n percent I is equal to 0, then number is not prime. Equal to 0, then it is not prime. Once you understand that it is not prime, you need not continue for the next changes. So you can exit. You can exit. So these two statements need curly bracket because these are two statements. If it is a single statement, then curly bracket is not necessary. So this is statement 4. Otherwise, we will just say that this number is actually prime. In that case, it is prime. So, if this condition is satisfied, then the program will end. Otherwise, it will continue, and when all the complete loop is over, still the condition is not satisfied, then it will print as not prime. Here it is giving error because to use exit, we have to include stdlib.h header file. So let's include that. stdlib.h. Now the error. Now let's run this program, get the value of n and check whether it is prime or not. Clear. So check all the cases. So 1 not defined. Check suppose 3 prime. Check suppose 10 not prime. Correct. Check suppose 31 prime. Very good. 50 not prime. Suppose 67 prime. Take any big number. Suppose 5, 5, 7. We don't know whether it is prime or not. It is prime. Okay. Any other number. Suppose 1, 0, 0, 1. Not prime. You can take any bigger number. 1, 9, 3, 4, 7, 5. Suppose. 7, 5, 1. Suppose. Not prime. So in this way it gives us message whether prime or not.